at Frankston, looking 37 kilometres across to the city of Melbourne in Australia, on a nice calm water, very level. Now, there's 4 chaps heading off in boats. John is starting on the shore at Frankston. He's meeting Paul in his boat 9 kilometres away, and then meeting George on the 18 kilometres away. Then Ringo joins in at 27 kilometres, and they all travel on to the 36 together. Now, John, in his first 9 kilometres, travels down on the curve, they say, 6.36 metres. His next 9 kilometres, he drops down more, it's 19.07 metres. His third 9 kilometres drops down 31.78 metres. And his last, the finish of his journey at the 36, drops down 44.23 metres. Now, you're probably getting the gist of this very quickly now. Paul starts off, his first 9 kilometres is 6.36 metres. His second is 19.07, and his third lot of 9 kilometres is 31.78 drop. Now he is going to continue on another 10 kilometres. Now George joins in, and he'll go through the same process, but he has 18 kilometres to go. Ringo travels his 9 and drops his 6.36. He has got another 27 kilometres to go. Now you can see that that is totally impossible. It's just illogical, and it doesn't work. You cannot have an increased curve on a ball when they're all travelling alongside each other. They can't possibly be going at different curves. Now, how they work that curve out, they have like a clock, and you'll see they come out on a tangent, and then they come down to the point they want to measure. So you can see by perception that that is increasing all the time. But then if you turn the clock around, 3 o'clock used to be a big curve. Now it looks flat. Now 6 o'clock looks flat. Now 9 o'clock looks flat. So you see, it is a constant curve, right around, constant. This model is totally wrong, can't be. Now I proved that if you live on a blue ball, there's a square inside it. If you move this around degree by degree, you'll find that the blue area always stays the same. And I'll show you in a moment, when I change the music, how there's a 10% curve. Okay, back to the curve. Have a triangle, and we're talking figures of 40,070 kilometres around the circumference of the ball Earth. The radius is 6,371 kilometres. So obviously this will be at a right angle, 6,371. Now, the hypotenuse is therefore 9,009 kilometres. So, when you pop, that didn't work. When you pop these around, fucked that up, didn't I? Big time. Okay, there you are. So you've got 4 hypotenuses. So when you see that you've got 9,009 by 4 hypotenuses, you get 36,036 kilometres deducted from the 40,075 of the circumference. That is 10% curve. So what we're saying, if you live on a ball, the curve is consistent and it's 10%. Now, I look across from Frankston to Melbourne and I can see the city, which with a 10% curve, consistent, would be down 3.7 kilometres. So it would be impossible. Therefore, you live on a flat plane. Now, you can forget about Einstein's idea with the ball Earth rotating at 1660 kilometres an hour, which is nearly the speed of a bullet, 1700 kilometres an hour. Now, he says we rotate around the sun at 107,000 kilometres an hour. The solar system turns around the Milky Way at 792,000 kilometres an hour, and our galaxy spins around other galaxies at 2.1 million kilometres an hour. 1,235 times the speed of a bullet. Totally impossible. Now, what they do, they show you a map which is derived from their ball Earth. Now, the measurements of these are probably pretty accurate, but the thing is, the North Pole is a centre and the North Star above it. The countries are all gathered around. You can travel around on a boat, no problems. Right around, either way. Now, so Australia there, that looks about right. There it is, nice big Australia. Basically, it's impossible that we live on this. What is beyond the ice wall, nobody knows, because it is protected. It's protected by military, that is well known. You can't cross over there. So what's beyond it, we don't know. But all we know is we don't live on a ball. Otherwise, I would not be able to see Melbourne from Frankston. Thank you.